we're going to do this webinar by John Ricketts. Well, John Ricketts and he corrected me. We met, I believe, in 2011 in a conference in Luxembourg, where he was the key speaker and I was doing an obscure little presentation after him, and that's where we met. And I wanted to meet him because I'd already read his book at the time, which was published in 2007, called Reaching the Goal, which is all about managing professional services, the theory of constraints way, and was and still is the bestseller with regards to applying the theory of constraints in services, at least professional services. So he worked for Big Blue, IBM, for many years. He's too modest to tell you he finished in fairly important positions dealing with strategy and stuff. And then he retired, which I will do soon also. And he couldn't think of anything better to do than spend his time writing, and he published this thing, Exceeding the Goal, a few months ago now, 3 months ago, something like that. And it's a fascinating book, and he's going to be basically talking about part of it today. I highly recommend this book. Basically, whatever your angle on the theory of constraints and on IT is, because it's just fascinating, very, very rich. And so much so that we're doing this webinar here as a sort of kickoff, but we plan to do a lot of various events and things and videos throughout the year, because we've been thinking hard about how to get all the messages across from his book. But for instance, John suggested that we do it chapter by chapter, but since there are 26 chapters, that might get to be a sort of Netflix series sort of thing. So we'll work it out. We'll be picking out the best of and putting out some videos about all that. Okay. So I'm going to hand over to John. The setup is John will speak for about an hour, and then we'll have about 30 minutes of questions and answers. You can use the buttons that allow you to type in your questions and answers. There's a Q&A button, or depending on the language in which you set up your Zoom, it might be different. But and there you can type in your questions. Maybe Etienne, who I haven't mentioned yet, you could just type in something in the Q&A just to make sure it's all working okay. But there's Zoom is slightly confusing because you can also type in things in the chat button, right? So you can do that also. And myself and Etienne, who appears under the logo of Maris Consulting, will be concatenating, reading all those messages so that we can then host the Q&A session. Okay, so please type in your questions as they come to you, and we'll use all that stuff to ask the grueling questions at the end, right? And Greg Beatty, by the way, says no pressure, John. Okay, so over to you, and take it away, John.
Thank you, Philip and Etienne. I'm honored to be able to present this webinar today. You know, Maris Consulting has been a leader in theory of constraints or constraint management for many, many years. So to some degree, I feel a little bit like I'm preaching to the choir here. As Philip was reading the list of countries that you participants come from, I was impressed. Some of you are showing incredible dedication, because I know based on where those countries lie, this webinar is not happening during normal business hours. So for those of you that are up late or up early, I salute you. As Philip mentioned, we've been kicking around ideas related to constraint management for quite some time. And we actually did another webinar similar to this a few months ago, and that webinar is available now out on YouTube if you're interested. The book that Philip alluded to, Exceeding the Goal, actually has 3 elements or 3 components to it, 2 of which we're going to talk about today in a fair amount of detail, and the third will save the details for subsequent videos. But the 3 elements that I'm alluding to are constraint management, information technology, and technical strategy. Technical strategy is the one that we're going to go light on today, but we'll cover more on a later date. Because this is an introductory video and one that's oriented towards an IT audience primarily, I'm going to do a fair amount of explaining what constraint management is, at least at a rudimentary level. And the previous video took the opposite tack on that. Because it was for the Theory of Constraints International Certification Organization, my assumption was that people attending that webinar knew constraint management to a fair degree and maybe didn't know IT as well. So I spent more time explaining IT to that audience than I will today. In any event, both of these videos together form the crossbar on what's sometimes referred to as a T-shaped curriculum, meaning we're going to go broad but not very deep today, and then in the subsequent videos we'll go much deeper but much narrower. So without further ado, let's take a look at the agenda. I've got 5 things in mind for today, and that is, number 1, we're going to look at some constraint management principles at a basic level, and then we'll take a look at the question, is Agile compatible with constraint management? I reckon those of you who are IT professionals or who work closely with IT professionals have been exposed to Agile, and you might have wondered whether anything into Theory of Constraints has applicability there, and so we're going to tackle that question. Then we're going to ask, does the constraint management approach to projects work in information technology? We're actually going to introduce you to a project management method that's been around for quite a while in Theory of Constraints or constraint management, but it's not a hot topic like Agile is. I think it's a topic, though, that nevertheless warrants some discussion. Which takes us then to, can constraint management handle IT staffing? What does constraint management say about IT portfolios? It's this 5th item where we're going to begin to get an introduction to technical strategy. And then, as Philip said, finally, we'll have an open question and answer session. So I encourage you to go ahead and answer your questions at any point, and we'll be sure to try to get to them before the end of this webinar. So IT is in the title of this webinar. I reckon everybody on this webinar has some notion of what IT is. What I find, though, is that sometimes people have a narrow view. They tend to think of it as personal computers and desk-side support. And I'm going to take a much broader view. Basically, anything to do with computers network and sensors attached to those computers and networks. So that will include hardware, software, data, services. All of that is in scope for what I'm referring to as IT. Next, I'd like to just say a couple words about general management before we talk about constraint management. I realize most of you on this call are already familiar with general management, but there's one nuance here that I want to emphasize, and that is, when I talk about operations, I'm talking about productive activities. In a manufacturing environment, that would be the production of physical goods. In a services environment, it would be the delivery of some kind of service, either from a labor-based perspective or from a technology-based perspective. We're in fact going to talk about some technology-based services later in this webinar. But the one that I wanted to emphasize on this page here is what I mean by strategy. So when I talk about strategy, I'm really talking about change initiatives so that we can figure out where we are, where we want to go, and what we have to change to get there. I'll also talk about enterprise strategy as distinct from technical strategy. As you can see here on this slide, the definition of enterprise strategy that I'm using is, how are we going to reach or exceed the goal that's been set for the enterprise? By enterprise, I mean not just businesses. I deliberately chose the word enterprise in lieu of business because the concepts that we're going to talk about here, I believe, are equally applicable to nonprofit organizations and to governmental organizations. So I didn't want to limit the discussion to just the business world. Finally, on this page, then you can see technical strategy comes down to how are we going to support the enterprise strategy? And if there's misalignment between the technical strategy and the enterprise strategy, then one or the other, or perhaps both of them, are going to suffer. So I'm going to describe constraint management in my own words here. If you read the constraint management literature, you're going to see a somewhat more detailed description that I'm giving you here, but people sometimes get tripped up by the wording, since the founder of theory of constraints, a fellow named Elie Goldratt, had English as his second language. Sometimes the words don't mean exactly what someone who has English as their first language would assume they mean. So this is my own words here. In a nutshell, constraint management involves step number 1, set a goal. Step number 2, identify what restricts goal attainment. Step 3, focus operations around that constraint for reasons that will become evident in a moment. And then execute strategy that continuously improves. So this is formally known as theory of constraints. I'm going to call it constraint management because that word theory sometimes confuses people or they misinterpret it. So from here on out, I'm going to refer to constraint management. And if there is a single core concept behind constraint management, it's manage the one thing that matters, not everything. And that runs against a lot of conventional wisdom. I know in business schools and in applied settings, managers oftentimes feel compelled to have their fingers in every slice of every pie. And not only is that wearisome for them, it can also be ineffective. What I like about constraint management is it helps you identify leverage points, a constraint, a bottleneck, one thing that's impeding the performance of an entire system. And because it's a leverage point, it means you don't have to manage everything. You can manage just a few things. Before we get into this, though, let me begin with just a little adventure. In the book that Philip alluded to, Exceeding the Goal, there are, I believe it's several dozen adventures. And an adventure is a short story, a true story. There's no fiction in the book. And those stories range from successes that I'm really proud of to, shall we say, less than successes that I'm a little bit apologetic for. In the extreme cases, there are some cautionary tales of things that really went pear-shaped. But the adventure that I'm going to recount for you here is one that was a success. And hopefully it'll give you a little bit of a feeling of how we've taken constraint management into the IT realm. So this is a story about how the client organization was optimizing a non-constraint in their information technology development organization. And by helping them re-envision where the constraint is and reorient their activities around that constraint, it led to not only solving the problem that they approached us with, but it improved their performance measurably from that point going forward. So what you see on the left-hand side of this table here is a very simple sequential set of steps that's undertaken to develop software. Requirements, design, code, test, production. And the as-is column represents the situation as presented to us when we walked in the door. The client was having difficulty with production. Too many errors, too many outages, and their belief was that their constraint was in testing. So when they would have an error and outage, they would circle back to recoding the parts of the programs that they believed were leading to those problems, and then they would retest and test and test and test and test, and yet they continued to have this problem. In discussions with them, though, it became evident that they really were operating intuitively. They didn't have very many measures of things they were doing. So what we helped them do was introduce defect metrics so that they could measure how many bugs there were per program and how many bugs they were removing per test cycle. Those two measures are called defect density and defect removal efficiency, respectively. And once they had those defect metrics in place, we worked back and looked at their code metrics about the programs that gave us insight into things like how complex was the code. And then finally, we recognized that there was a hole where they didn't have any metrics at all. And I'm referring now to design metrics. It turns out that the root cause of many of the problems that they were experiencing in production did not have their origin in the coding. They had their origin in the design. Some of the designs were so complicated that they were effectively untestable. And by providing these metrics, it gave the development organization more insight into whether they were moving the ball forward, because they could see the metrics change as they changed the design, and they could see the code metrics change as the design improved. So this is an example of identifying the real constraint in an IT environment and having it bear fruit for the development organization. Which takes us then to the first of several principles that I want to talk about here. What I'm going to do is describe principles in the context of manufacturing, not because I necessarily expect those of you on this call to be manufacturing experts, but because the things that flow through a manufacturing environment are physical. And I find through experience that it's easier for people to picture that than it is to picture abstract things flowing through an IT development organization. So we're going to talk about some principles here, and then we're going to turn right around and see how these principles apply in an IT setting. First principle is the constraint principle. The constraint is that thing that restricts production. So it has to be an element of a system or closely allied with a system. I mentioned my definition of enterprise a few moments ago. So if we're talking about an enterprise system, it could be a factory, or it could be a function like accounting, or it could be a project like a system development project. There can be constraints in those enterprise systems. Likewise, there can be constraints in an information system. It's less the case nowadays that hardware is a constraint than it used to be, because hardware used to be very, very expensive compared to what it is today. More often today, what you find in an IT system is the constraint is in the software. But if you think about these two parallel but separate systems, those that are running the enterprise and those that are in IT, it's possible to identify constraints in both of them. So we may have, we may need to consider both classes of constraints as we go forward. Something else to keep in mind when we're talking about constraints is the boundaries that define the edges of the system that you're trying to understand the constraint for. One of the things that characterizes businesses today is that they're actually systems of enterprise systems. So you have systems for marketing and for production and for distribution and finance and HR and so forth. When you go to a manager in any one of those systems and you talk to them about constraints, they will all easily be able to point to a constraint in their system. Whether or not that local system, though, harbors the constraint for the enterprise is an open question. In fact, most of them will not be the enterprise constraint. They still, however, may warrant constraint management because they consume investment dollars and they consume operating expense, but they aren't revenue generators if they're not part of the enterprise constraint. Some other terminology to get under our belt here is that constraints can be internal, meaning inside the system, or in some cases they can be external. In fact, when you look at enterprise constraints and you ask yourself, what is it that really restricts the enterprise's ability to generate revenue and profit? Oftentimes nowadays, in about 70% of the cases, the constraint is actually external. It's out in the market somewhere, meaning that the enterprise could produce more goods and services than the market is willing to consume. We're going to start by talking about internal constraints, and we can talk about external constraints more later. Which then takes us to operations constraints versus strategic constraints. Essentially, my definition of those is that the operations constraint is whatever is presently restricting the throughput or the production of the system. And the strategic constraint is what you will move to in the future. So it restricts your future. So let's apply this constraint principle to this diagram that represents a manufacturing environment. On the left, we've got raw material that's able to be dispensed at 300 units or more per time period. And then production flows into step A, which produces 300 units per time period. And then that flows into BCD, probably 3 identical machines, each of which produce 90 units per period, but collectively they're 270 units. So if you compare A to BCD, you can see that BCD has capacity less than A. And therefore, given as far as we've made our way through this diagram, one would conclude that BCD is more likely to be the constraint than A is, since A has more capacity. If we continue on to the right, we can see HT has 250 units of productive capability per unit of time, which is less than BCD, so HT becomes our new candidate for the constraint. In fact, if we look on to the right, we can see that X and FA both produce more than HT does, so HT is the constraint in this context. One of the things that happens, though, in environments today is if you look closely at where the boundaries are, you sometimes find that the constraint is not where you thought it was. I mean, it's typical to go through a mental exercise like I just went with you here when looking at the direct manufacturing activities. But if you examine ancillary activities, what you may find is that the constraint is actually elsewhere. In this case, it's represented as being in quality assurance, because quality assurance can only inspect 240 units per period and HT produces 250. QA is actually the constraint here. But let's go back to the original situation and assume that QA has more than enough capacity. Let's ask ourselves what happens in this context if the constraint's capacity increases. And there was a subtle change here as I flicked through the bullets. HT's capacity increased up to 300, which means now it has more capacity than BCD, and therefore BCD is the constraint now. So when you tinker with capacity in an environment like this, you may be shifting the constraint around, and one of the questions you should ask yourself is, have I put the constraint in a strategic location, one that actually increases the benefit to the enterprise as a whole? Now what I've done is increase the capacity of all the elements here so that they all can produce 300 units per time period. That in fact is what's striven for if you're into lean. You know, lean strives to have balanced productive capacity so that you can have a minimum of work in process. Lean is a very laudable objective. It works best if you've got a stable environment, though. If you have a turbulent manufacturing environment, meaning you have new products coming in, old products going out, new workers coming in, old ones going out, change in machine, change in marketing. If you have a turbulent environment, then having an unbalanced capacity can actually be to your advantage because it gives you a single control point. With a lean environment like you're seeing depicted here, if you have a disruption any place, it becomes a disruption every place. And that's not the case with a constraint management solution that's unbalanced. As we'll see as we go through the rest of this example, a disruption in one place doesn't necessarily ripple elsewhere. So to finish out this slide, let's ask ourselves, what happens if demand is less than production? This is that external constraint that I was alluding to on the previous slide. If demand is less than production, we wind up overproducing and we wind up with excess finished goods inventory. All right, on to the next principle, utilization. Utilization is the ratio of productive time to available time. And conventional wisdom says utilization matters everywhere. That's why in the old days, in a manufacturing environment, they would watch the utilization of every machine and every worker and try to get all of them up to 100%. And an unintended consequence of that management mindset was it overloads the constraint. In constraint management, utilization really only matters at the constraint. And if you try to utilize non-constraints over 100% or up to 100%, then it just overloads the constraint. So let's go back to this diagram that we were looking at a couple slides ago and see what happens if we maximize utilization. So here we've got 100% utilization on everything up through HT, and then it trails off because HT's capacity, because it's the constraint, its capacity is less than the others, then they're not being fed enough work in process to achieve 100%. But an unintended consequence of overloading the constraint is the excess work in process accumulates upstream, but it also creates some level of chaos in the manufacturing environment. And so you wind up with inventory being stacked everywhere. The gray boxes on the right here represent inventory that may be work in process inventory that it represents jobs that were started too early or jobs that are waiting on some components from upstream. So if you walk into a manufacturing environment and you see inventory everywhere, it's probably because they're following the utilization principle inappropriately. What happens in this case is you wind up with late jobs causing cancellations, discounts, and lost sales. Clearly not something you would strive for. So let me introduce the concept of buffers. A buffer is something that decouples elements so that a disruption is less likely to ripple throughout the entire system. And those buffers can be tangible. In the example that we've seen on the previous slides, the work in process inventory is physical work in process inventory or stock. Another way that you can manage buffers in a manufacturing environment is to use space as the buffer, to literally paint lines on the floor and say any work in process that's inside the boundaries represented by those lines, that's our buffer for the machines that are going to work on that stock. But for an IT environment, I need to introduce the notion that buffers can be intangible. We're going to see a project management method after a while where the buffer is time, contingency in other words. But if the system in question is a financial system, the buffer could be cash. If the system is one that provides human resources, then the buffer is skills, and so forth. The specific buffer type depends on the flow type in the system under examination, in other words. Buffers are sized to accommodate normal variation. So if something abnormal happens, then you may have to sprint to resolve the problem. But what I love about sizing buffers for normal variation is it means most of the time the system operates without a lot of management intervention. And that allows management to spend more of its time thinking about strategic matters rather than fighting fires at the operational level. Another way to say that is that management attention is required only if a buffer is approaching depletion. We're going to see buffers depicted with colored zones in a while, red being bad, green being good, yellow being somewhere in between. It's only when the buffer approaches depletion, meaning it gets into the red zone, that management attention is required. Which then takes us back to this diagram. If we ask ourselves, where's the buffer? The answer is it's all work in process ahead of the constraint. So I'm assuming here that HT is the constraint, and there you can see the gray shaded area represents all the work in process in the buffer. What happens to utilization and excess work in process? If you manage the buffer, then utilization on these steps upstream decreases, but the work in process melts away. And so the chaos that we saw in the previous slide or two melts away as the excess work in process melts away. Which then takes us to a pull principle. Conventional wisdom says managers should push work through a system. Push, 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 because otherwise things don't get done in an expeditious manner. Frequent expediting, large batches, and excess work in process are symptoms of that mindset. Constraint management instead says, look, we're going to establish some rules, some practices, and some measurements that pull work through the system on demand so that we're not producing excess inventory and we're not spending effort needlessly. If we apply the pull principle to this now familiar diagram, we can pull work through the system by monitoring the buffer, and when we see buffer holes appear, we can release jobs to fill those holes. And as long as we do that and keep that buffer level in the green zone, management doesn't have to worry about the rest of the production. It's going to take care of itself. On the other hand, if we have an external constraint, meaning that the market isn't buying everything that we can produce, if we only keep if if we keep the buffer full, we're going to be overproducing. So we need a different trigger that pulls work through the system. And that different trigger is demand from the marketplace. So in this scenario, if the marketplace is only demanding 200 units, then we would release 200 units per period into step A. We would expect to get 200 units out of BCD, 200 out of HT, which is less than its capacity. So in that circumstance, the factory would not be 100% utilized, including the constraint. All right, one other thought about buffers though is, if you think strategically, it might be advantageous to put a buffer elsewhere in this manufacturing process. What you can see here is a buffer being established at step X to feed into FA. And the reason for doing that is, if the total duration to go from raw material to finished goods were, let's say, a month, and you instead put a buffer at X, it might be that you would be able to offer to the marketplace the ability to deliver in 1 week instead of a month. And if all your competitors are delivering in a month and you can deliver in a week, that gives you a competitive advantage based on speed. So the point here is that buffers can be strategically placed not only to manage the constraint, but also to create competitive advantage. Which takes us then to the time principle. Idle time on an internal constraint is bad, but on non-constraints, some idle time is inevitable. However, time lost on a constraint is time lost by an entire system. So what happens if the constraint has an outage? The system overall produces less. But if a non-constraint has an outage, the upstream tasks can sprint, meaning they can produce more than the constraint can. And likewise, the downstream elements can sprint to finish late jobs faster. So that's what I meant when I said earlier that this kind of unbalanced productive capacity means that the enterprise is more resilient to disruptions. So, do these constraint management principles apply to IT? We haven't seen that yet, but I'm going to give you a foreshadowing here that yes, they do. I need to acknowledge, though, that constraint management principles were derived from systems consisting of a series of dependent events, just like we saw in the manufacturing examples. And IT is a little different. That means that constraint management has been a bit more of a struggle for people to apply than it was in manufacturing. Because in the IT world, the systems in question are more a set of interdependent events. You know, software projects are not just you do A, B, C, D in a linear fashion or a sequential fashion. There's considerable iteration as discoveries are made of requirements and as experiences gained with alternative designs and implementations and code and so forth. It's just not as linear as manufacturing. Likewise, because IT, as I've defined it, also includes services, what we find is that there are aspects of IT that involve completely independent events. Technical support, for instance, may involve calls from 10 different clients, and each of those clients has a completely different and unrelated problem. So those independent events might make you think, I wonder if CM really applies in the IT realm. Let me give you an assurance up front that it does, and we'll see how in a little while. So despite these differences, constraint management principles do apply to IT. A couple things about IT, though, that we'll keep in mind as we apply those principles is, in manufacturing, when there's no work in process, production stops. I mean, there's literally nothing to run through a machine. On the other hand, in IT, there's always work to be done because work doesn't always depend on physical work in process. A lot of what we do is intangible. It might be written down on paper, it might not, it might be carried around in people's heads. The tasks that we perform are often semi-autonomous. So the people performing those tasks have a lot of discretion as to which task they work on and whether they split their time between this task and another task, this project and another project. And the requirements that they're given to work on may be imprecise. There's a lot of judgment and interpretation required. Finally, you can see here, operations on 24/7. So the conclusion that I'm headed toward in all this is that in IT, There's a lot of real work to be done, but if you don't manage the constraint, people will find work to do, and I'm calling that busy work here in the conclusion. But I don't mean that in a pejorative sense. I just mean it's work that's maybe not as important as things that they could be doing if the constraint were being managed. You may have been asked, why on earth is IT a perpetual bottleneck? You tend to hear that from people trying to manage enterprise systems, and they've been stymied because they want some IT capability, and IT either can't deliver it at all, or they can't deliver it on the time frame that the project sponsor has in mind. My short answer to that is IT is a bottleneck only if you let it be, and we're going to manage constraints because if we don't manage the constraint's going to manage us. Which takes us then to the goal of IT. It's important to keep in mind that IT serves different roles across organizations. IT in many enterprises is an enabler of core business. So payroll is an example. Payroll doesn't generate revenue unless you happen to be in the payroll business. Doesn't generate any revenue for your organization, and yet it's an essential function. You know, it's a requirement that you can't live without because you can't operate without paying your employees. At the other end of the spectrum, there are enterprises where IT is the business. As Philip mentioned, I used to work for a large IT company, and the revenue that we got was directly from the hardware, the software, and the services that we delivered. Between those two extremes, though, IT can serve a role as an adjunct to the business. And this is common in manufacturing today, where a manufacturer that's been producing products for a long time has awakened to the possibility that they can deliver ancillary services. You know, maybe they haven't done maintenance, repair, and operations before, MRO, and they open up a new business and they have to have IT to go along with that, and that becomes a separate source of revenue. In fact, having an app that displays data that's being produced by the physical products could be a separate revenue stream. Similarly, it's possible to embed IT in products and services. And in that case, it generates revenue, but the revenue is indirect and not as separable as if it were an adjunct business. So the goal of IT might affect, you know, how much interest we have in a particular constraint. Could be that we have a constraint in payroll, and we're just not going to give it as much attention as a constraint that we have in marketing, because marketing generates revenue and HR doesn't. Another point to keep in mind here is that information can be a differentiator or a barrier or a commodity. And so its importance relative to the strategy of the enterprise can vary widely from enterprise to enterprise. So if you ask yourself in IT, where is the constraint? It can be a lot of places. Where it is really depends on your role and where you draw the system boundaries. If you're a project manager, for example, the constraint you're going to be most interested in is the constraint for your project. If you're the CIO, your constraint might be budget, and you have to figure out how to accommodate the multitude of requests that are being made upon your organization, and you're going to have to pick and choose where to spend those precious budget dollars. Same thing goes for people who are managing enterprise systems. If you're in marketing, you know, you're going to see a different constraint than the CFO will. When we're talking about operational level systems, though, it's helpful to think in terms of that system having just one constraint. There are exceptions. You know, it's possible to have both an internal and an external constraint. If you've got a division that has two product lines and one of them is ascending, so there's a lot of demand, and the other one is descending in terms of demand, you could have an internal constraint for product A and an external constraint for product B. However, as we're going to apply these principles, I find it helpful to encourage people to think in terms of operations level systems having just one constraint at a time. At the enterprise level, however, you need to think in terms of multiple solutions for multiple constraints. The CIO, as I alluded to moments ago, is probably concerned about budget and how to allocate it sensibly across the multitude of demands. But that CIO also has to bear in mind that each of the projects that are being worked on within his or her sphere has its own constraint. So multiple solutions for multiple constraints. One more slide before we talk about how to apply the principles in IT. Information systems come in a variety of forms. And if you hear me speak of systems of record, I'm referring to systems that gather and maintain data for the enterprise. So a customer master record, product master record, sales records, all of those are examples of things that would be kept in systems of record. For mature organizations, those systems may be old in the sense that they weren't built just last year. They may have been built a decade or more ago, but they are literally running the business. You might be surprised at how many business rules are embedded in that kind of system. Nowadays, however, enterprises need more than just systems of record. A system of insight is one that creates actionable information. So if you've got some market intelligence data and you plug that into a system and you generate a map that shows you where the demand is and where it's moving to, and based on that analysis, you're able to redeploy your marketing and sales efforts, that's an example of a system of insight creating actionable information. System of engagement is one that involves social networking, Twitter being an example. Nowadays, when enterprises create systems of insight, systems of engagement, and systems of innovation, which we'll get to in a moment, oftentimes they need to access data that's in those systems of record. And that creates a two-speed IT problem that we'll delve into more in a little while. But first, let me just acknowledge that there's a fourth category of systems here called systems of innovation. So those reinvent processes, products, services. Those of you who might have implemented TOC software or constraint management software will have found that it really does reinvent the process. The point that I'm leading to here is that one methodology doesn't necessarily fit all of these different system types. It may be that the systems of record are so large that they follow a planned methodology and they release new versions of the software quarterly or semi-annually. Systems of engagement, though, may need to be developed quickly in just a matter of a month or two. And then they need to be tweaked quite a bit to follow the trends that are captivating your market nowadays. If you were to wait for quarterly releases on a system of engagement, that may be way too slow. Where you run into problems, and this is the two-speed IT problem, is if you've got one developer group working on a quarterly schedule and another group working on a 2-week schedule. That creates problems because the deployment of a new social networking app might be delayed by several weeks or even months while waiting for data that it needs from another system. We'll talk more about how to resolve the two-speed IT problem in a while. But now let's take these principles and begin to apply them in the IT world. I reckon if you've been around IT at all, you've heard of Agile. And this is my little simple diagram of how Agile works. Ideas turn into requirements, which then are fed over to developers who produce deliverables, and then there's a blue line here that goes back to the beginning. So it's highly iterative is the implication of this little diagram here. And when I ask people who are engaged in Agile projects, where is your constraint? Most common answer is it's developers. And in fact, that's actually the intent of the Agile philosophy, is for developers to be the limiting factor. So to the degree that we can keep the developers busy, we're going to get 100% utilization of the constraint. It's possible, though, for the constraint to be requirements. And that happens when the product manager, whose job it is to prioritize the requirements coming from users, either gets behind in their work or gets distracted and has to go off and do something other than their project management role, or maybe the role is unfilled. I know of enterprises where the developers they appear busy, but they're working on things that aren't the most important things that they could be working on because the requirements haven't been prioritized. Similarly, the constraint could actually turn out to be the ideas coming from users and project sponsors. And to the degree that they're not coming up with new requirements, then the rest of the activities that follow subsequently aren't focused on the most important work that could be done. Another possibility is that the constraint is actually in the time between deliverables, but Agile doesn't really manage that the way another methodology does that we'll look at in a little while. So we're not going to spend much time talking about the sprint or time between deliverables as a constraint. The point here is that even though people who are engaged in Agile method don't necessarily think of constraints beyond the developer should be the constraint, every system has a constraint whether you manage it or not. And to the degree that you let the constraint slip in an Agile environment, you cause slack time or busy work in the downstream activities. So you might ask yourself here, if the developers are the constraint, where's the buffer? The answer is the buffer includes work in process. So it's the documents, it's the thoughts having to do with design and coding and testing and training and so forth. But the buffer also includes requirements. And it also includes the ideas. So the buffer is all of that stuff to the left of the developers in this context. And the conclusion that I'm trying to lead you toward is the earlier the constraint, the shorter the buffer. So when you have a disruption, it disrupts more if the constraint is actually toward the left in this diagram than if it's toward the right. So how does pull work? The developers, their ability to say to the rest of the team, you know, I've got some time now, what should I work on next? Their availability pulls requirements into work in process. So they go to the requirements list, they look at what's toward the top, the highest priority, pop it off that stack and go to work on it. And commitments to the project sponsor, to users, pull the work in process through to deliverables. If we were to, instead of using the pull concept here, we were to push developers, what we wind up doing is forcing them to engage in bad multitasking. And for developers, multitasking is a problem because it just disrupts mental flow time. You know, the nature of development work is such that you really need to concentrate, and it takes about 20 minutes to get into that deep level of concentration. So if you're interrupted every 15 minutes, you never really get deep into thoughts. And that's why you find developers working after hours, working off site, working with headphones on if they're forced to work in an office. All that is their attempt to avoid the interruptions that bad multitasking imposes upon them. And so working on too many requirements at once actually, it gives the illusion of progress, but if you look at the actual output of an IT development organization, the output is actually less when people get distracted. So this pull principle that we saw in a manufacturing environment and we're now thinking of in an IT development environment is meant to focus people on the most important IT work. Which then takes us to this slightly different diagram of an Agile project. You'll notice that I've introduced here operations, support, and maintenance as additional activities. And this DevOps approach involves developers multitasking among not just development, but also these other activities. And the prevailing philosophy behind this push is who knows better than developers how to handle the additional duties. And I sympathize with that. I recognize that if an Agile team is only 3 people or 9 people or some number in between, that's a pretty small team. And for them to have to do a handoff to an operations organization, the philosophy is that that would be more disruptive and less effective than just keeping all these activities within the development team. What I find though is that the bigger the organization, the bigger the development team, the less well that commingling of duties serves the organization. And I think there's a valid reason for why over the years there's been a separation between operations and development. Part of it has to do with efficiency. Other reasons for doing it have to do with security and privacy. If you separate duties, then it requires collusion rather than a single perpetrator of bad actions. Anyway, we're not going to have time for it in today's webinar, but I invite you to engage in this mental exercise offline and ask yourself, what happens to the constraint? What happens to the buffer? And how well does pull work if the developers also have responsibility for operations, support, and maintenance? Which takes us then to a transition point in this webinar. I'm going to talk about IT project management methods here beyond just Agile. But I first want to remind you of the iron triangle of project management, which says, you know, you can have a good, fast, or cheap. You get to pick any two. And I tee that up as a lead into this slide because I'm going to compare Agile with a method that comes from constraint management called critical chain. So this is going to be a very rudimentary, but I hope enlightening introduction to critical chain as another tool that IT developers can have in their toolkit. And what you'll see is that it has a different philosophy with respect to the iron triangle of project management. So on the left-hand side, you can see that the row labels begin with domain and end with the objective for these methods. And then the 2 columns represent the methods that I want to compare and contrast. The Agile method was developed for software. And the scope of work that's accomplished by an Agile method is variable depending on the nature of the requirements, how complex they are, and their priority. So a 2-week sprint on an Agile project might deliver a lot of work in sprint number 1 and less work in sprint number 2 because sprint number 2 involves something really, really complicated. It looks smaller, but it was complicated. And so sprint 1 might deliver an app or 2, and the following sprint might deliver just a database. In other words, the variable scope. But the resources tend to be fixed. You know, if it's a 3-person team for sprint 1, it tends to be that same 3-person sprint for sprint 2, 3, 4, and so forth. So the resources over time tend to be fixed in number. And whether the time between releases is fixed or variable depends on the specific Agile method. There are, I believe, 60 different variants on Agile method. And the one that I've been alluding to so far is called Scrum. Scrum is the one that has 2-week fixed intervals on releases. An alternative to that is called Kanban. And with Kanban, the time between releases is still short, but it's variable. It could be a week, it could be a week and a half, it could be 2 weeks, it could be 2.5 weeks, variable delivery time. But no matter which Agile method you use, the deliverables are small and infrequent. And oftentimes the objective is to create a minimum viable product and to do it quickly. So Agile implements an 80-20 rule, meaning 20% of the requirements for any system may account for up to 80% of the value that system delivers. And rather than produce 100% of the requirements, if you can produce the 20% that's really critical up front, you accelerate the business benefits. And if you never get to the other 80%, then you conserve on your investment in that IT solution. So the minimum viable product says do the most important stuff first, and the less important stuff you may never get around to, and that's really okay. Critical chain, though, takes a different philosophy on that, in that critical chain is meant for situations where if you deliver less than 100%, you've got a problem. You know, think about building a bridge. If you don't deliver 100% of the requirements on a bridge, do you really want to put your family in the van and drive across that bridge if it doesn't have guardrails and lights and a second lane and good supports underneath? No, you really want to drive across that bridge when it's been fully built to satisfy all the requirements. Critical chain was invented for a manufacturing environment, but it's been widely used elsewhere, including services and including software. There are times when software has to be complete. And so in row 2 here, the scope row, you'll see that with critical chain, I said the scope is fixed. You know, it's all relative. Nothing is really 100% fixed. But compared to Agile, you can think of the scope of a critical chain project as being more fixed. Later on, when we do a deep dive on critical chain, we'll talk about ways to cope with the uncertainty and requirements in IT. But for now, think of it like critical chain would be useful in building a data center. You really need all the elements in place when you build a data center, or it's not going to be secure and it's not going to work because it won't have power or light or environmental controls. But with a critical chain project, the resources that work on the project are not fixed. If you need designers, they come in and do the design. If you need coders, they do the coding. If you need testers, they come in and do the testing. So over time, people move on to and off of a project. And the time or the schedule for a critical chain project really depends on its scope. The deliverables tend to be larger and less frequent, but critical chain can produce a fully viable product. So let's take a look at a very, very, very simplified view of a critical chain project plan. This is a Gantt chart. So each one of these numbered boxes represents a task. Time flows from left to right. And if we ask ourselves, where is the constraints in this project? It's the things that I've shaded in blue here. Activities 1 through 5 plus 9 through 10. So the critical chain is the longest path through the plan. And although I've drawn the boxes having the same length here, that's just for illustration purposes. In a real project plan, there would be many more boxes, hundreds perhaps, and they would be of a length, you know, representing the actual estimated duration. One of the things that makes critical chain different from other planned methodologies that you may be familiar with is that task durations are planned at 50% probability of completion by that date. And let me just pause for a second, because that may be a little bit mind-blowing if you've never seen critical chain before. Because critical chain is in some ways an unfortunate name. Many of you may be aware of a planned project method called critical path. It's been around for a long, long, long time. With critical path, what people do is they plan task durations with 80, 90, 95% probability of being able to complete the task by the date, that the end date for that task. And the way they accomplish that is they embed a lot of contingency into the estimate. So if you think it's really going to take you 3 days to do this task, but your manager, may load some other work on you and you're going to get distracted, you might estimate that task at 5 days instead of 3. Those additional 2 days are the contingency that I alluded to. And what happens during project execution is that contingency typically gets squandered. And so you have a late task finish, and that ripples into the next task and so on and so forth. So late task finishes tend to become cumulative. Critical chain takes a completely different approach. It plans task durations at 50% probability, but it takes the contingency and it sticks it out in buffers that protect the entire project. You see 2 buffers here represented as PB on the right, that stands for project buffer. And then for tasks 6, 7, and 8, they are followed by something labeled FB, that stands for feeder buffer. More about those buffers in a moment. But coming back to the idea that task durations are estimated at 50% probability, that means that if you aren't distracted and you don't engage in bad multitasking and you just do the tasks that you've been assigned, You work it like you're participating in a relay race. Some tasks will finish early, some tasks will finish late. On the average, they should finish on time. And if you do have an accumulation of late finishes, your project buffer protects the date that you've committed to finish the project by. So contingency gets moved into buffers. The assumption here, though, is that resources aren't the constraint. They assume that you can get the resources to do the project according to the plan. So in addition to having a project manager who's putting together a viable plan, you need a resource manager who's planning to assign the resources on demand as they're needed when the project is executed. So this little diagram represents the chain principle. It's not one that I introduced earlier. This seemed like an appropriate time to do that. What it says is that a system produces only as much as its weakest link will allow, and in this case, the weakest link is the longest path through the project. So moving on, if we ask ourselves, where are the buffers here? You can see them in gray. However, I've redrawn the buffer here so that it is divided into 3 zones. And I think you can see that if, let's say, project 10 finishes late, in effect, it slides right on this timeline and intrudes into the green zone of the project buffer, which is fine. That will happen occasionally. Hopefully, somewhere else in a project, when you have a late task finish, there will be another task that will finish early, and it will pull the buffer penetration back to the left. But over time, if late projects accumulate and you wind up penetrating into the yellow zone or into the red zone, when it gets to the red zone, that's really when management needs to act. So it lessens the demand on managers' time to be concerned about every late project finish, because some of them will be offset by early finishes. Similar to the way that I divided the project buffer into zones, here I've divided the feeder buffer into zones. And what the feeder buffer does is it protects convergence points. What we wouldn't want to do is execute tasks 1 through 5 and get all them done on time and have tasks 6, 7, and 8 finish late. That would disrupt the critical chain. So we insert a feeder buffer whenever there's this convergence of tasks. The committed date, however, includes the buffers. So when you're putting together your project plan and you're telling your customer, you know, I can commit to having this done by May 10th. May 10th is the date out there at the end of that red project buffer zone. What that means is that this kind of project plan is not just shorter than an equivalent critical path plan. The critical chain plan has a much higher probability of on-time completion. In organizations that have become mature in their application of this kind of planning and execution methodology, what we find is that their on-time completion is in the realm of 95%. One last caveat that I will offer, though, is that sponsors ask for speed when what they want is predictability. So if there's a marketing promotion that's going to happen in 6 months, or there's a new product introduction that's going to happen in 6 months, what the project sponsors may ask for is to have new IT capability in support of the marketing and the delivery of the product be done in 3 months, because they want their own buffer and make sure the IT is going to be there in time. And they do that because IT's track record of success in honing to their estimates is not particularly good. So the mindset of the project sponsor might be, if I demand it in 3 months, I have a reasonable probability that it's going to be done in 5 months, and therefore I'll be safe on my 6-month commitment. Well, with critical chain, if you have a 95% probability of it finishing on time, it may be the case that you can make a commitment to the client to finishing it in 5 months instead of 3 months. And the client can trust that commitment because they understand how critical chain works. The reason from an IT perspective for doing that is a 5-month project is a different kind of project from a 3-month project. The additional time means you could introduce more tools, you might use different skills. It's just a different project, and one that we would expect would have a better quality deliverable at the end of the 5 months than something that would hurry to be done in 3 months. So it's a situation where both parties can benefit from the longer schedule. How does pull work? Well, tasks start when their predecessors finish. Once you kick off the project, you no longer pay attention to start dates on tasks, however. You know, if you think about how you ran races in high school, when the person who had the baton came around, you didn't wait to grab that baton and run. You would grab it and run just as fast as you could, because that's how relay races work. That's not how projects typically work, though, when they're being managed according to start dates. You know, in a relay race, you wouldn't stop and work on your math homework while you're holding the baton. That's just not in the spirit of it. So not doing bad multitasking is the essence of the relay race principle. Something else that I said in the agenda that I would cover is the application of constraint management to resources. And this is actually the very first solution for services that we did using a constraint management toolkit. Here you can see we've got a job market on the left, we've got projects on the right. We want to be able to hire skills and assign skilled persons to accomplish those projects. So where's the constraint? Well, the constraint is on skills requiring lead time to hire and get on board. If we can hire people off the street and put them to work tomorrow, that's not really a constraint. But if we have to take a multi-month period of time to interview candidates, to select the ones that show the most promise, and then get them on board and trained, you know, you're not going to be able to respond to demands for staffing a project tomorrow. You're going to be able to respond in 90 days or more. And yet that's how some organizations work. They hired a plan. They say, we think we're going to do this many projects in second quarter, and so we're going to hire people to satisfy that anticipated demand. Well, then if demand is exceeded or falls short, you wind up with either overstaffing or understaffing. So the solution that we came up with to apply constraint management to resource management was, forget about the forecasts. We're going to establish a buffer, and we're going to hire to demand. So here you can see on the right, we've got a project, people being assigned into that project out of a skills buffer. When they finish their work on that project, they go back into the skills buffer. And if we are fortunate enough to sell a lot of projects and need more people, we replenish the buffer from the job market. This buffer is a little different from the ones that we've seen before, though, because it's bidirectional. Instead of being green, yellow, red, which is a unidirectional buffer, here we've got a bidirectional buffer that's red on both ends. That's simply an acknowledgement of too many is bad, likewise too few is too bad. So the buffer is core skill groups, those that take some time to hire and on board. It does not include commodity skills, ones that we can hire off the street. Likewise, it doesn't include critical skill groups. I mean, critical skills are those where if we could hire enough to have a buffer, we would do so, but the skills are just not that plentiful. In my experience, IT architects are an example of a skill group where you can try to set a buffer, but if it's ever above zero, that's a surprise, because everybody you hire, you can put to work on projects right away. Which takes us then to pull. Pull works off of the buffer level. You know, when the buffer level falls into the low range of the red zone, then you would replenish from the job market. And in the interest of time, I'm going to move on to the measurement principle here. It's been said that measures drive behavior. The corollary to that is mismeasures drive misbehavior. If IT has no metrics about its work, then development can go awry. Guesstimates lead to risky commitments. Problems are hard to diagnose. Performance improvement isn't quantifiable. So this is a little bit of insight into technical strategy. We'll go into more depth in a subsequent video, but what I wanted to do was show you this diagram so that we can talk about applying constraint management principles to an IT portfolio, where a portfolio includes a spectrum of projects. As you can see here on the left, there is a vertical axis labeled scope, and on the horizontal axis, it's labeled schedule. So scope you can think of in terms of number of apps being delivered or number of screens, number of reports. It's something that project sponsors and users will acknowledge as a deliverable that fulfills a requirement. On the horizontal axis, we've got schedule. That's the elapsed time to perform a project, with longer projects being toward the right. Within the body of this diagram, you can see that there are some open dots that represent active projects, and you can see some closed dots that are color green that represent finished projects. Similarly, if you really squint at it, you can see that this dashed blue line represents a minimum viable product frontier. It's the amount of time that it takes to go from 0 to a minimum viable product. If you look closely, you can see that there's a cluster toward the lower left that represents small projects. As you might imagine, they're small by definition because they have small scope, but they're also short because that scope is short. There's a cluster to the right of that that represents medium-sized projects, and then another cluster to the right of that that represents large projects. If I click on this button to show you the fully viable product frontier, you'll see that it passes through the completed projects and it forms an arc. Those two arcs, the MVP and FVP frontiers, create an envelope. It's the envelope of successfully completed projects or projects that are on their way to success because they're in process right now. And if you have this kind of information, it equips you to ask questions when you get an estimate of a project like number 1 that you now see appearing toward the bottom of the screen. If I take project number 1, which is yellow in color, and I project it onto the MVP frontier, we can draw a couple of conclusions from that. The overarching conclusion is that this project appears to have been estimated with a considerable amount of slack, because the projection onto the frontier says, if we really are going to allocate that schedule to this project, we ought to be able to get about 40% more scope or work out of the project. Conversely, if we hold the scope to what is represented by dot number 1, it looks like the schedule could be half of what we've actually estimated. So is this a viable and credible project estimate or not? Well, it might be. It might be that there's something novel about the requirements that really puts it in a different category from any of the work that's been done before. If we're doing a project in artificial intelligence or machine learning for the first time, it's just going to be harder than anything we've done before. So we may need to allow extra time for that. So I'm not meaning to imply that this is necessarily a schedule where, because it's unlike anything we've done before, we ought to cut the schedule back or we ought to ask for more scope. I'm not saying that at all. I'm saying the conversation around the estimates here can be enlightening, and we might decide that this is a perfectly valid estimate, but it's the conversation that's important. Similarly, when I bring up project number 2, we can see that it's outside the envelope in the opposite direction. And once again, I'm doing a projection here. And we draw a somewhat different conclusion on this one, though. If we hold scope to what is being proposed, it looks like the schedule ought to be about twice what's being proposed. So that should be raising a red flag. Alternatively, if we hold the schedule of what's being proposed, then it looks like the scope is maybe a quarter less than what we would expect based on prior successful projects. So number 2 is a stretch project. It's somebody saying, you know, we need something, we need it fast, we need it big, and we've never done one like this before. So if an IT manager looks at this, they ought to be asking themselves, okay, how could we do this bigger project in a shorter time frame? Maybe we need to put our best people on it. Maybe we need to adopt a different tool. Maybe we should acquire the software rather than writing it ourselves. You know, there are many answers to the question of how do we get to end of job on a stretch project like this. But once again, it's the conversation that's important. And if you don't have this kind of data about your portfolio, then you don't know when you're outside the envelope. Which takes me then to 3 and 4 and 5. The further you get outside that envelope, the harder the conversation ought to be. You know, number 3 is a longer project than anything has ever been done before. Whether sponsors will wait that long for their deliverables is a valid question. Number 4 is off the scale in the sense that it's bigger than anything we've ever built before. And number 5 is an agglomeration of all of those sins. It's not only bigger, it's longer. It's way on out there. And I've seen people's careers falter because they committed to something that was just way beyond the capability of the organization. So how could you contend with that? Maybe 5 could be broken up into a series of projects that would fit down within the envelope, each of those individual projects being less risky than the mega project out there in outer space. So this slide is a review of constraint management. It's different words from what we saw early in the presentation, but it's consistent with what we've seen before. And to review, we've seen constraint management principles. We compared Agile to constraint management principles. We looked at critical chain as the constraint management approach to projects that could work in IT from a planned project perspective. We briefly looked at a constraint management approach to IT staffing, and we had a quick look at constraint management and what it says about IT portfolios, and it warns us against committing to fantasy projects. There's a lot more to be discussed there, but that's all we had time for today. So if you're asking yourselves where you could go next, here's a long list of possibilities. Let me suggest that the first one is one that's an interesting exercise. You might ask yourself, what % of your IT portfolio is actually targeted on the enterprise constraint? And if the answer is low or none, clearly that's something that you could tackle right away. I'll let you read the rest of these. We have a PDF that's available so you can look at these offline. I will point out that in considering potential topics for future webinars, this slide, page 40 in the deck, lists some IT pain points and some potential constraint management topics. So I'd be interested to hear either during the Q&A session or during offline communications. You can comment on LinkedIn and let us know what you'd like to hear more about, and we'll take that into consideration. So with that, let me end it on this slide here, just a reminder that there are some books out there if you'd like to do a deeper dive on your own. We've got Reaching the Goal and Exceeding the Goal. You can see Philip there waving it around right now. So Philip, let me hand it back to you, buddy.
Thank you, John, for preparing this and doing this. And John and I will be doing lots and lots of stuff to give you more content and ideas such as we did today. So thank you very much for your time, all of you. Very impressive to see still 100 people listening in after so long. But let's call it a day. And if you didn't find the answers in the webinar, buy the book. You might have noticed he even puts you what pages you have to read, depending on the slide. It's really cool. Okay, so mille merci to everybody, and see you around next time. Bye-bye.